So last time we talked about parallelograms. A parallelogram is a quadrilateral with two pairs of parallel sides. When we have a parallelogram, we say that the opposite sides are parallel, opposite sides are congruent, the opposite angles are congruent, consecutive angles supplementary, and the diagonals bisect each other. When we look at today's notes, lesson 6.3, rectangles, rhombi, and squares, we are dealing with special parallelograms. A rectangle is a special parallelogram with four right angles. So it is a parallelogram with four right angles. So here's a picture of a rectangle. We call it rectangle ABCD. Now, don't forget, it is a parallelogram. It has all of those properties. We say that the opposite sides are parallel. We say that the opposite sides are congruent. The opposite angles are congruent, but don't forget, it's a rectangle. All of the angles are right. And then the consecutive angles are supplementary. So let's take a look at the properties here. Properties of rectangles. All four angles are right angles. The diagonals are congruent. And they bisect each other. Right, so if I'm looking at this picture over here, we know for sure that we have a rectangle, all angles are right. But if we look at the diagonals, so here's diagonal 1 and here's diagonal 2. Since a rectangle is a parallelogram, of course the diagonals are going to bisect each other. They are segment bisectors. Well, they're going to bisect each other at a midpoint. And of course, if I'm looking at MK, the midpoint is going to split this diagonal into two congruent parts. But here's the thing. The length of this diagonal is equal to the length of that diagonal. So if I'm looking at the midpoint of JL, well, we know it's going to split that segment into two congruent parts. But how many tick marks do I put here and there? Well, I actually put one here and one there because remember, the diagonals of a rectangle are congruent. All right, so let's move on to a rhombus. A rhombus is a special parallelogram with four congruent sides. So here's a picture of a rhombus. It's a parallelogram, meaning it has all those properties. The opposite sides are parallel. The opposite sides are congruent, but since it's a rhombus, what's so special about a rhombus is that it has four congruent sides. So we actually put one tick mark for each to tell the reader that all the sides are congruent. And then we have the opposite angles are congruent. And then the consecutive angles are supplementary. But if we talk about the diagonals of a rhombus, if a parallelogram is a rhombus, then its diagonals are perpendicular. So if I look at diagonal AC, it's going to intersect diagonal BD at a 90-degree angle. So we can say that line segment AC is perpendicular to line segment BD. Remember, when you have a rhombus, the diagonals are going to intersect each other at 90 degrees. The next thing that you need to know is if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. And this is just a long way of saying that the diagonals serve as angle bisectors. So, when you have angle bisectors, the angles are going to split into two congruent parts. So if I look at this diagonal here, well, it's going to split angle P into two congruent angles. And we can say the same thing about angle R. It's going to split it into two congruent angles. If we look at this diagonal over here, it's the same idea. This diagonal is going to split angle N into two congruent angles, and it's going to split Q into two congruent angles. So that means if parallelogram NPQR is a rhombus, then angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 is congruent to angle 6, and angle 7 is congruent to angle 8. Alright, so we're going to go ahead and move on to a square. Now, you probably have heard of the phrase that a square is a rectangle, but a rectangle isn't a square. And I'm going to go ahead and tell you why. Now, a square is a special parallelogram. It is a parallelogram with 4 right angles. So a square is a parallelogram with 4 right angles, and if I look at the definition of a rectangle, it is also a parallelogram with 4 right angles. What I'm trying to say here is that a square borrows that idea, borrows that definition from a rectangle. But a square isn't just a parallelogram with 4 right angles, it also has 4 congruent sides. So it is a parallelogram with 4 congruent sides. That's basically a rhombus because, a rhombus is a parallelogram with 4 congruent sides, right? So that just steals the idea from a rhombus. So due to the fact that the definition of a square makes it both a rectangle and a rhombus, it has all the properties of both. So really, a square is a rectangle and a rhombus. Remember, it is a parallelogram. It has all those properties that we talked about. We can go ahead and say the diagonals are congruent and bisect each other, right? Because if we look at the diagonals of a rectangle, we said that if you look at the measure of this diagonal and compare that to the measure of that diagonal, they are the same. And since both the rectangle and a square are parallelograms, the diagonals are going to bisect each other, right? They're going to bisect each other at a midpoint, and the midpoint is going to do its thing where it's going to split segments into 2 congruent parts. Since we have the diagonals being the same, we can put 1 tick mark here and 1 tick mark there. And we can also put 1 tick mark here and 1 tick mark there. So the diagonals are congruent and they bisect each other. That just steals the idea from a rectangle. The diagonals are angle bisectors. That's taking that idea from a rhombus. And then we cannot forget this, the diagonals are perpendicular. So what's going to happen is that when you have the diagonals, they're going to intersect at a 90-degree angle, okay? Okay, so let's take, so we need to put this here first. So the diagonals are perpendicular. That's a property of a rhombus. So when you have a square, don't forget the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, but since it is a rectangle, all of the angles are right. And then the consecutive angles are supplementary. Now, the diagonals, if you have the diagonals here, the diagonals are going to bisect each other at a midpoint, and it's going to split, let's say, DB into two congruent parts. But since this diagonal is the same length as this diagonal, well, if we have our midpoint, it's going to split AC into two congruent parts, but we're going to have the same number of tick marks, meaning that this part is equal to that part, this part is equal to that part, and then, so on and so forth. I think you get the idea here. All right. And then don't forget, the diagonals are going to intersect each other at a 90-degree angle here. And you can also say the same thing here, here, and there. Okay, so let's take a look at this example here. Quadrilateral JKM is a rectangle. So since I know that this is a rectangle, I'm just going to mark my picture. I'm going to state the properties again because that's the only way I can do the problem. The opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent, but since it's a rectangle, all four angles are right. Okay? And then the consecutive angles are supplementary. Now let's take a look at the diagonals. The diagonals of a parallelogram bisect each other at a midpoint. But since this is a rectangle, the length of this diagonal is equal to the length of that diagonal. So it's going to split MK into two congruent parts. So I put 1, 2, 3 tick marks, 1, 2, 3 tick marks here and there respectively. Again, the diagonals are equal in measure. So if I'm looking here, it's going to split JL into two congruent parts, but I don't put 4 tick marks here and there. I actually put 3 tick marks because the diagonals, the two diagonals, are equal in measure. Okay? All right, so if I'm looking at JP is 3y minus 5 and MK is 5y plus 1, we need to find y. JP is 3y minus 5 and MK is 5y plus 1. Find the value of y. So what is the equation going to look like in order for me to find the value of y? Well, I see that, okay, remember, we have a rectangle, and these parts, well, we're dealing with diagonals, right? If I'm looking at the parts here, this part in green is not going to equal to this part in pink. In fact, what we need to do here is that if we look very, very carefully, I need 2 of the greens to equal the whole pink. So I can say that I need 2 times the quantity of 3y minus 5 is equal to 5y plus 1. And then I need to do my algebra. I should get 6y minus 10 equals 5y plus 1. So your answer is going to be 11. B, if the measure of angle JKL, so measure angle JKL is 5x plus 15, so JKL, I'm referring to this angle here, find the value of x. If we're looking at this angle and we know that it's 5x plus 15, notice that we marked a 90-degree angle there. If the measure of angle JKL is 90 degrees, well, we know from the problem it is also 5x plus 15. So what do I do with the two things that I said? We just set them equal to each other, so we should have 5x plus 15 equals 90. And then I do my algebra, x is equal to 15. All right? Okay, let's take a look at the back side here. Quadrilateral FGHJ is a rhombus with diagonals intersecting at K. Use the given information to find each measure or value. What's something that we know about a rhombus? Well, a rhombus, of course, is a parallelogram. It has four congruent sides. The diagonals are perpendicular, and the diagonals are angle bisectors. So these are the properties of a rhombus you should know. If I'm looking at A, if the measure of angle FJH is 82, so we're looking at FJH, this angle here is 82 degrees. Find the measure angle KHJ. So I'm looking at this angle here. All right, well, we know we have diagonals, right? The diagonals are perpendicular to each other. So that's something important to know. So there's a 90-degree angle here, 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 and there. And we know that the diagonals are angle bisectors. If I look at this diagonal, it's going to split angle FJH into two congruent parts. So if we know that this whole thing is 82, me splitting the 82 would give me 41 here and 41 there. What we need to do with this information is find the measure of angle KHJ. This is what I'm looking for. And what I see is I have a triangle. And you know that the sum of the interior angles of a triangle is 180 degrees. I have 90, I have 41, and I need to figure out what this angle here is. What is the measure of this angle? Well, I can simply do 180 minus 90 minus 41, and that's going to give me 49 degrees. So that is the measure of angle KHJ. Now, I'm not going to go ahead and do B because it's the same thing as A. Let's move on to C. If the measure of angle GKH is 12x minus 6, find the value of x. Well, we know that the diagonals of a rhombus intersect each other at 90 degrees. They're perpendicular to each other. So we're going to go ahead and give this a little box. And since the measure of angle GKH is 12x minus 6, and at the same time it's a right angle, I can do 12x minus 6 equals 90. So I should get 12x equals 96, so x is equal to 8. X is equal to 8. Okay, so that's C. If I'm looking at D, if GH is x plus 9 and JH is 5x minus 2, find the value of x. Okay, so if we look carefully, we're dealing with the sides. Since we're dealing with a rhombus, well, a rhombus is a parallelogram with four congruent sides. So all the sides are congruent to each other. So what I need to do with these two expressions here is I set them equal to each other. And what I'm going to get is x is equal to 11 over 4, or 2.75 if you want to give the decimal. All right, so those are examples of using the properties of a rhombus to our advantage. Let's go ahead and move on to this next thing where we have a quadrilateral, PQRS, is a square. Now, since we have a square, it has properties of a rectangle and a rhombus. So if I look at this picture without looking at the questions here, I want to say that the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and then don't forget the diagonals. The diagonals are perpendicular, and they create a midpoint, and it's going to split PR into two congruent parts. And since the diagonals of a square are the same, if I'm looking at the midpoint of SQ, we don't put 3 tick marks here and there, we actually just put 2. All right, so that's good that we marked the picture. Now what I'm going to do is I'm going to look at the question. So if the measure PM is 5, find the value of each measure. We know that PM is 5, so let's go ahead and circle that. PM is 5. So PM is 5. Then what is the measure of SM? So SM, we know that PM is 5 and it is congruent to SM. So if this is 5, then this has to be 5. So the measure of SM is 5. For B, what I'm going to do is I'm going to skip this for now and move on to C and D. The measure of angle MQR, so MQR, well, what is this angle here? What is this angle here? I'm not talking about this whole angle. I'm not talking about angle Q. It's MQR. It's this angle. Well, we know that the diagonals are angle bisectors. If this is 90 degrees and this is the diagonal, which is my angle bisector, it's going to split the 90 degrees into 2 congruent parts. So we have 2 congruent angles. So the best way to do this is I take that 90, that full 90, divide that by 2, and that's going to give me 45 degrees. That is the measure of angle MQR. For D, we have the measure of angle PMS, so PMS. Well, that angle that I highlighted is a right angle. Okay, so the measure of angle PMS is just simply 90 degrees. Now, if you notice, I did A, C, and D, but did not do B, because this one's a little tricky. So, what is the value of PS? I cannot say that this is 5, right? This is 5, and this is 5, and they have the same number of tick marks. This one has 1, right? So it cannot be 5. And if I look very, very carefully, the sides are not given at all. We don't have a number here, 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 and there. We have to figure this out. And in order for me to figure this out, we have to, well, let's go ahead and redraw the picture. Or I should say that I'm going to draw this picture and just tell you what's going on here. All right, so I have a triangle, and we said it was a right triangle, and these two sides are congruent to each other. So this is 5, and this is 5. And let me go ahead and just label the vertices. So this is P, M, and then S, okay? What is PS? If we look at our figure that we drew, we have a right triangle. And if you are given a right triangle, or if you have a right triangle, then a squared plus b squared equals c squared. That is what we call the Pythagorean theorem. Okay, so it's a squared plus b squared equals c squared, where c will always be the side across from the 90-degree angle. C is what we call the hypotenuse, and the hypotenuse of a right triangle is the longest side. Okay, so what is C, or the hypotenuse? That is what we're trying to figure out, so we don't know. So we're just going to call this C and just leave this alone. But what we do know is our A and B. We'll call this A and we'll call this B. It doesn't matter which one you call A and B. The only thing that matters here is that you know what the hypotenuse is, which in this case is our unknown, what we're trying to figure out. And we have A, which is 5 squared, plus B, which is 5 squared. And remember from Algebra 1, in order for me to take this off, or in other words, how do I get rid of the exponent of 2? I need to take the square root on both sides. You can only take the square root if the variable squared is alone on one side of the equal sign. So the square root and the exponent of 2, they'll go away. So you have C on the right-hand side, and then we have the square root of 5 squared plus 5 squared. And if we look, 5 squared is 25, plus 5 squared, which is also 25. So what you're dealing with here is the square root of 50. Let's take the square root of 50 and put that into our calculator, okay? And I hope this doesn't confuse you. I know with my black pen, there is this dot. That is the dot of this I. So really, let's go ahead and move this over here so you're not confused, okay? So C is equal to the square root of 50. If I put that into my calculator, C is going to be approximately, but not quite exact. It's going to be close. C is approximately 7.1. Okay, so that is the value of PS. Okay? All right. Now, the next thing that I'm going to do is I'm going to go through this problem where we have a quadrilateral named JKLM with vertices J, -7, -2, K, 0, 4, L, 9, 2, and M, 2, -4. And we're going to see if this quadrilateral is a parallelogram, okay? So let's plot these points first. So -7, -2, that's J, K is 0, 4, L is 9, 2, and M is 2, -4. I'm going to connect the dots. I should have a quadrilateral, so you should have 4 sides. Okay, so here is my quadrilateral. Now we're going to go ahead and determine the slopes of the diagonals and see what happened there. I'm going to go ahead and create my diagonals. So we should have a diagonal from K to M and a diagonal from L to J. So let's find the slope of the diagonals. So remember the slope formula is M equals y2 minus y1 over x2 minus x1. So if I were to find the slope of this diagonal, JL, then that's going to give me, after using my formula here, that's going to give me 1 over 4. Okay? But on your homework, I know I didn't show any work here, but please, please, please make sure that you're showing your work on your homework assignment. So I know that you know how to use the slope formula, okay? The next thing that I want to do is look at the slope of the other diagonal, which is Km. So Km, and after using the slope formula, you should get -4. Now, what we're going to do with these two slopes is compare the two. We see that we have 1/4 and -4. So if I look at the signs, this is positive and this is negative, so the signs changed. And if I look at 1/4, if I flip it, that's going to become 4, or 4/1. So these are perpendicular to each other because we have opposite reciprocal slopes. So we can say that the diagonals are perpendicular. So what could it be? Could it be a rectangle? Could it be a square? Could it be a rhombus? Well, the diagonals of a rectangle, they don't intersect each other at 90 degrees. If we look carefully, the diagonals intersect, but this is not a 90-degree angle. These things here are obtuse angles, and these things here are acute angles. Could it be a rhombus? Of course, the diagonals of a rhombus are perpendicular, and we can also say the same thing for a square, right? So what I'm trying to say here is that we eliminated that this figure could be a rectangle, but this figure could potentially be a rhombus or square. Okay, so we're done with this part. We're done with part A. Now what we're going to do is we're going to determine if the diagonals are congruent. So the best way to figure if the diagonals are congruent is by using the distance formula. So the distance formula is d equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 the quantity squared. So I got to find the distance between J and L and the distance between K and M. So if I were to find the distance of JL, then I just take the square root and say -7 minus 9 the quantity squared plus -2 minus 2 the quantity squared, and that's going to be approximately 16.1. That's the distance of JL. If I want to find the distance of KM, then I have the square root of 0 minus 2 the quantity squared plus 4 plus 4 the quantity squared, which is approximately 8.2. We know that the diagonals are perpendicular, but the diagonals are not congruent. So I'm going to say not congruent. So since the diagonals are perpendicular and the diagonals are not congruent, we conclude that the quadrilateral, so therefore the quadrilateral, which is a parallelogram, is a rhombus. Okay? If the diagonals are perpendicular and the diagonals are congruent, then we can say that it is a square. But since the diagonals are not congruent, but we know the diagonals are perpendicular, then we can say that it is a rhombus. All right?